From the unique vantage point of the Space Shuttle Atlantis, we can see the separation of two diverse environments. All around us is the endless vacuum of space, a void where humans cannot survive without elaborate life support systems. And below us, like a blue and white oasis in the middle of a lifeless desert, is Earth, a place of abundant life. Separating these two extreme environments is a thin and fragile shell of gases we call our atmosphere. In thickness, the atmosphere is to the Earth like the fuzz is to a tennis ball. But in spite of its relative thinness, the atmosphere is vitally important to life on Earth. It's the atmosphere that gives us the air we breathe. It regulates our climate to make the Earth habitable. And it's a filter that screens out much of the sun's harmful radiation while allowing the radiation needed for life to pass through. It should come as no surprise that life as we know it would cease to exist if our atmosphere didn't perform its unique functions. But recently, scientists have begun to detect that our atmosphere has been experiencing mysterious new changes, changes that appear to be the result of human activity, changes that could ultimately affect our lives in a major way. Many of you may have heard about ozone depletion, the greenhouse effect, and global warming. All of these are related to the changes that are taking place in our atmosphere. But do any of you know who or what is causing the changes? As a scientist, I've always considered myself a detective of sorts, investigating the Earth and its environment, asking important questions that hopefully will lead to practical solutions. Join me now, and let's see if together we can solve the mystery of who or what are responsible for changes to our atmosphere below.
T-minus 10, 9, 8. We have a go for main engine start. We have main engine start. 4, 3, 2, 1, 0, and liftoff. Liftoff of the space shuttle, and it has cleared the tower.
Looks like slow. It is slow. That's the case. Yeah, you're
your touchdown.
Let's begin our investigation by finding out what's happening to the ozone. First, we'll need to ask a few questions to get some background. For starters, what is ozone?
Ozone is oxygen, but not the kind we normally think of. A regular oxygen molecule is formed by two oxygen atoms that are bonded together. But ozone molecules are different. They have three oxygen atoms bonded together. Ozone can be made in a laboratory on the ground where we can study its characteristics. Ozone is also made naturally in the upper atmosphere. There, ultraviolet light from the sun breaks the bond in molecular oxygen to form two separate atoms. These atoms may then join with other molecules to form ozone.
Why is ozone so special? Well, without ozone in our atmosphere, I would probably need a sunscreen protection factor of 500. And probably even that would not be enough.
You see, ozone blocks ultraviolet radiation. Up in the stratosphere, ozone forms a very thin layer. So thin that for every 1 million gas molecules, only 10 are ozone. But even as thin as it is, the ozone layer is able to screen out most of the sun's harmful UV rays.
But having an ozone layer means much more to us than just having to cut back on the amount of sunscreen we have to buy.
Ozone is important to all life on Earth, because without it, scientists believe cases of skin cancer and eye cataracts would increase. And since sunscreen only helps humans, animals would be unprotected. Crops and plant life would also be affected, and that would upset the Earth's entire ecological system.
In fact, the diversity of life as we know it would change drastically if ozone disappeared from the atmosphere.
By looking at the atmosphere from space with just our eyes, we can't tell if anything is happening to the ozone layer or not. But scientific instruments carried on weather balloons, sounding rockets, and satellites show us revealing evidence that ozone levels are decreasing over much of the Earth. From September through November, ozone levels decrease over Antarctica. This is what's called the ozone hole. The ozone hole allows more ultraviolet radiation to reach Antarctica than would otherwise do so. But changes in ozone concentration are more complex than just the appearance of seasonal holes. So now we know ozone levels over many parts of the world are decreasing, and we know some of the chemicals that play in this game. But a good detective always has to look beyond the obvious. We have to ask ourselves, where do these chemicals come from? Two of the suspects are the chemical compounds chlorofluorocarbons, also known as CFCs, and oxides of nitrogen, which have many faces. Here's why we suspect them. In the upper atmosphere, these compounds react with sunlight and are broken down into smaller parts. The CFCs give off chlorine atoms, while nitrogen oxides form nitric oxide. There they are joined by other chemicals containing hydrogen, sulfur, and other atoms. When these chemicals encounter ozone, a reaction occurs that strips away an atom of oxygen from the ozone molecule. The products of these reactions react with ozone also. Just a small amount of chlorine and nitric oxide can create a cycle that destroys many ozone molecules. It looks like we may have some of the key players responsible for the ozone destruction, but there are a lot more detail to be worked out. A good detective always looks beyond the obvious. We've got to ask ourselves, where are these chemicals coming from?
They come from many sources. Hydrogen compounds come from the gas methane that's formed by agricultural activities such as rice production and the cattle industry. Decaying vegetation in swamps also produces methane.
Chlorofluorocarbons, or CFCs, are made by humans. One form of this chemical is the gas used in our refrigerators and air conditioning units to chill the air. It's also used to blow insulating foam and clean electrical components.
Nitrogen compounds come from many sources. Exhaust emission from high-flying supersonic aircraft is only one of them. Nitrogen is also released into the atmosphere during lightning storms in tropical regions. Many chemical fertilizers that we use to grow our food are nitrogen-based, and they lead to increased releases of nitrous oxide into the atmosphere too.
So, now we know that Mother Nature and humans both contribute to the decreasing ozone. But does that mean that one of them is more responsible than the other? Well, we don't know for certain. That part of the mystery requires more investigation, and that's why we're here.
During this space flight, we are observing the atmosphere and the sun with several sophisticated instruments. The data we gather will not only improve our knowledge of the amounts of ozone-depleting chemicals found in the atmosphere, it will also help us to better understand the role the sun's radiation plays.
When the facts are all in, we'll have a better understanding of the distribution of ozone-depleting chemicals in the atmosphere. Now let's turn our attention to another mystery of the changing atmosphere below.
You know, summers here in Houston can be pretty hot. It's hard to imagine it could get much hotter, but some scientists say it's actually happening.
Actually, Earth's climate has changed many times over millions of years. We've had ice ages, and we've had warmer periods.
That's because several factors that affect the climate of the Earth vary over time. One of these is the concentration of carbon dioxide, a gas present in the atmosphere in very small quantities. Here's how it works.
Picture a primeval setting with lots of volcanic activity. As the volcanoes erupt, they spew large amounts of carbon dioxide into the atmosphere. Carbon dioxide is what we call a greenhouse gas. That's because it blankets the Earth and traps heat, much the same as a greenhouse does. In a greenhouse, incoming radiation from the sun passes through the translucent roof unhindered. But the heat radiated back from the Earth is trapped by the glass. This trapped heat causes the temperature in the greenhouse to rise. The same thing happens in the atmosphere if carbon dioxide increases. Heat becomes trapped under the atmospheric blanket, and global temperatures will rise by a few degrees.
So what's a few degrees? The Earth's temperature changes every day when the sun goes down.
Well, the slightly warmer global temperatures can cause other changes to happen.
Polar ice caps and mountain glaciers begin to melt, adding fresh water to the oceans. And ocean water itself expands as it warms. Together, these two changes can cause ocean levels to rise, flooding lowlands. Warmer temperatures, along with sufficient rainfall, also mean that more green plants grow. But to some extent, ocean water and vegetation both naturally absorb carbon dioxide from the air. So with more ocean surface and more vegetation, more carbon dioxide is removed from the atmosphere. Eventually, enough carbon dioxide may be removed from the atmosphere so that the greenhouse effect begins to diminish and the Earth begins to cool again.
Of course, climate change is not that simple. There are a lot of other factors too. Some of the same chemicals that are hurting the ozone layer contribute to global warming.
Also, things like photosynthesis, respiration, ocean currents, forest fires, and fluctuations in the amount of energy generated by the sun.
So if the Earth's temperature varies a few degrees, what's the big mystery?
Measurements of CO2 in air samples trapped in ice indicate that levels of carbon dioxide are increasing. Our planet appears to be warming more than normal. This is another mystery of where and who. Where is this excess carbon dioxide coming from, and who or what is responsible for it?
From here in space, we can see some natural sources of carbon dioxide. Volcanoes and naturally caused forest fires. But many human activities are also releasing carbon dioxide. For more than 100 years, the fossil fuel burning machines of the Industrial Revolution have dumped millions of tons of carbon dioxide into the atmosphere. At the same time, the harvesting of forests and clearing land for cultivation is reducing vegetation cover. Vegetation uses carbon dioxide for growth, and in doing so tends to limit atmospheric increases of carbon dioxide.
So once again, we find both nature and humans are causing our atmosphere to change. Are these relatively rapid changes leading to a major warming? That part of the investigation is still underway.
In 1991, the Upper Atmospheric Research Satellite, or UARS, was launched from the Space Shuttle Discovery. UARS is using 10 highly sophisticated sensors to conduct a long-term study of the atmosphere. It will compile the most complete data ever collected on energy input from the sun, winds, and atmospheric composition. This information will add to the clues we have for solving the mystery of ozone depletion and global warming.
But another part of the investigation is happening right here on the Space Shuttle Atlantis.
Our atmospheric laboratory for applications in science is gathering important information about the atmosphere, such as what trace gases and chemicals are present in the atmosphere and in what quantities, and what is the ultraviolet radiation output of the sun. The UARS satellite and this mission are the start of a long-term investigation of the interaction of the sun's energy with Earth's atmosphere. The goal is to better understand how chemicals in the atmosphere reacting with the sun's changing energy levels are affecting our environment.
There are obviously a lot more questions that need to be asked and answered before we can completely solve the mysteries of our changing atmosphere. It's going to take far more than a single satellite or a single shuttle mission to solve this puzzle. This investigation is going to take long-term study by many dedicated scientists. Some of the people who ultimately will unravel all these clues and solve the mystery are probably sitting right beside you at this very moment. Now the question is, will you be one of them?